Hello everyone, this is part 4 of the AZ-204 exam covering caching and application monitoring. So if you enjoyed this, please like and subscribe. And with that being said, let's just get into it. Let me start by talking about caching. So what is caching? Caching is essentially storing temporary information in a high-speed data storage system. So the keywords here are temporary and high-speed data storage system. And caching is used to increase the performance of your applications and decrease the load on the backend. So, for example, when you use a web browser, some of the data that you retrieve from servers are cached locally on the web browser, so that next time you make the same request, this data is being retrieved from this temporary cache store in your browser, which would avoid those multiple round trips to the backend servers. So this is what caching essentially is. Now, the example I gave you is with regards to the web browser, but for backends, there's also an element of cache there. And the most popular database used for caching is known as Redis Cache. So this is by far the most popular cache or data storage system. And to show a quick diagram on how Redis Cache is typically configured in the backend, typically you would have a web server and a database. So the difference between Redis Cache and a traditional database is that Redis Cache stores data in memory or in RAM, while traditional databases store data in the disk. So when you have data stored in RAM, obviously it is much faster to retrieve this data. So this goes back to the definition of a cache being that it's temporary, meaning that it is in this case stored in RAM. So obviously you don't want to store long-term information in RAM. And at the same time, it is high speed. So when you are retrieving data from RAM, it is obviously much faster than retrieving it from disk. So this is the popular highlight of Redis Cache. Now, this is the typical architecture as mentioned. And in this case, the client talks to a web server, which in turn makes a trip to the database to retrieve the data from the database. And once it retrieves the data from a database, it caches this data on Redis Cache, so that next time the user, when he makes the same request, the server will not go back to the database, but will instead retrieve data from the Redis cache, essentially improving performance because this data again is stored in RAM, meaning that it is accessed much faster. Now, before going into any code examples, I just wanted to highlight that I installed Redis Cache locally on my machine. Now, obviously in production, you would have Redis Cache in a standalone server, but for demonstration purposes, I have it installed locally on my machine, and I will provide instructions on how to install Redis both on Windows and Mac in the description below. So once you install Redis on Windows, in this case, this is Windows subsystem for Linux. So that's why you see Linux in this case. So if I type Redis server, I open up the connection to the Redis cache. So now it's saying that it's ready to accept connections from me. So I will initiate those connections from a different tab. So if I type redis-cli, this is the CLI that allows me to interact with the Redis store. So what I can do is I can use the standard Redis commands. Again, this is not a Redis course. This is more about Azure Cache for Redis and some of the functionalities it offers and the use cases behind using caching. But for this specific case, I just wanted to highlight that Redis Cache is essentially a key value storage system, meaning that it simply stores key value pairs. It does not store JSON, it does not store tables, columns, etc. It simply stores key value pairs. Okay, so if I type, for example, set name, Abdullah, so it's giving me okay, meaning that if I go grab the key, I will get the value, which is Abdullah in this case. So everything is stored in key value pairs in Redis Cache. So now that I have Redis Cache open and ready to accept connections on this specific port, let me go through the code logic very quickly. Again, this is not a coding course, but I just want to explain the logic here very quickly. So anytime the user goes to this route, my application will make an API call to this endpoint. And once it retrieves data from this API call, I will cache, or it will cache the data on the Redis cache using this command, okay, for this specified number of seconds. And then after that, we'll return the response to the user. So the next time the user accesses this route again, my application will instead get the data from the Redis cache instead of making this API call again. Okay, significantly increasing performance in this case. So if I want to run that and show you a quick example, so let's type node app.js, and if I go to Postman and if I send this request, notice how long it takes to get back those responses. Okay, in this case, it's 782 milliseconds. So now I would expect my application to cache this response in Redis Cache so that next time I make a request, my application will actually retrieve data from the cache instead of making another API call. And let's test this and see how it goes. Notice how much time this is significantly reduced. So it's down to 5 milliseconds because my application is now retrieving data from Redis instead of making another API call. Now let's talk about Azure Cache for Redis. And this is something that you will be tested on in the exam. So you won't be tested on basic Redis concepts. You won't be tested on interacting with Redis through code. This is what you will be tested on in the exam, but I've just explained those concepts to give you a better idea on why Redis is used and in what scenarios it is used. So essentially, Azure Cache for Redis is a managed Redis cache on Azure. So it's a platform as a service on Azure, where you essentially don't have to manage the hardware, you don't have to manage any patching, securities, etc. All you have is just Redis on Azure that you interact with, and you don't have to worry about the underlying infrastructure at all. So this is what we mean by managed Redis cache on Azure. Now, we have many different pricing tiers when it comes to Azure Redis Cache, and I just want to touch on them very quickly, but I think this diagram is self-explanatory. So the basic just runs on a single VM, the standard run on 2 VMs, premium it's meant for high performance. You know, there's some extra features like lower latency, high throughput, etc. The interesting ones are actually the enterprise ones, and the enterprise ones are actually powered by Redis Labs enterprise software. Okay, so if you have maybe a license there, if you are already leveraging Redis Labs enterprise software, you can essentially host this on Azure, and it offers a lot of extra capabilities like Redis Search, Redis Bloom, etc. outside the scope of this exam. And then there's also the enterprise flash, which is basically the cost-effective solution for the enterprise tier. So what are some of the features of Azure Cache for Redis? The first feature is that it is obviously managed, meaning that you don't have to worry about the underlying infrastructure, and this is actually a major benefit. The second benefit is that it is highly available. A third benefit is that there's automatic failover, so meaning that if a specific a region goes down, there's automatic failover to a secondary region, so you can configure things like these very easily. And then lastly, you get the monitoring capabilities. You know, whenever you rely on a managed service on Azure, you get monitoring capabilities built in that you can then leverage as part of your monitoring strategy. So this is how the Azure Cache for Redis looks like in the portal. You get a couple of different settings. You know, some of the prominent ones are the scale, where you essentially seamlessly scale up to more powerful instances. You have things like geo-replication, for example, if you want to replicate your Redis cache across different regions. You have things like private endpoint, and you can integrate it with a firewall. Essentially, you can restrict specific IP addresses to talk to this Redis cache instance. And then there's, as mentioned, built-in monitoring capabilities with this insights feature that you can then create alerts based on them. Now I will talk about one of the most popular services that we use to cache content in, and that is Content Delivery Network, or sometimes referred to as CDN. Now, if you search the internet, you might find a lot of confusing definitions about CDNs, you know, being globally distributed, you know, increasing performance, etc. A lot of confusing stuff on the internet. So I'm going to try to come up with the simplest definition I can think of when it comes to Content Delivery Network. So a CDN is essentially a set of reverse proxies distributed around the world, and that's it. Okay, nothing more, nothing less. It is simply a set of reverse proxies distributed around the world, and we typically cache content on those reverse proxies. Okay, now those reverse proxies are distributed around the world to make sure that they are actually as close to the user as possible. Okay, so let me explain that in a diagram. Actually, this is typically the architecture that you will see with CDNs. Okay, so you essentially have a central server. In this example, the server is located in the UK, and you have many different clients distributed all around the world, especially if you have a global application. Okay, so this user can be based in Europe, this user can be based in the US, and this user can be based in Asia. And then you have a set of reverse proxies or CDNs distributed around the world. So you would rely on providers like Akamai, Cloudflare, who already have those infrastructures distributed all around the world. Okay. So now the way this works is that the user actually accesses resources from that web server via this CDN resource. Okay. So let's say the user is actually requesting, for example, an image. If he wants to view his own images or images of his friends, etc., he will typically make an API call to the server, but that call will actually go through the CDN. And once it goes through the CDN, typically this content is actually cached on the CDN. So that next time the user visits this, tries to access the same resource, he will actually retrieve it from the CDN resource itself. Okay, so the CDNs are typically used to cache content closer to the users or as close to the users as possible. Okay, and you might ask, what are some of the things that we cache on CDNs? The answer to that is typically static content. Okay, so by static content, I refer to images, I refer to files, I refer to videos, it could be HTML files, CSS files, etc. And if you think about it, 90% of web traffic is actually static. Okay, so just because of the fact that you cache static content all around the world, you are significantly improving performance for your users. Okay, so that is like one of the major benefits of using a CDN. The second major benefit, and the benefit also related to performance, is not just related to caching, okay? Even if you don't cache things on the CDN, you still get performance improvements because the traffic route between the CDN and the backend is actually much more optimized, okay? So even if you don't rely on caching, you still get performance improvements if you just use a CDN, okay? Now, the third major benefit, or let's say the second major benefit to using a CDN in addition to performance, is actually security. Okay, because you have those set of reverse proxies distributed all around the world, you are countering one of the most popular security attacks, which are DDoS or distributed denial of service attacks. Okay, the reason why this method or this architecture or using a cloud or using a CDN actually counters this attack is because you don't have a central resource to attack. Okay, all of those proxies are essentially distributed around the world, so you don't have a centralized resource that clients can abuse. Okay, so by definition or out of the box, whenever you are relying on CDNs, you actually gain protection from DDoS attacks. So this is the second or the third major benefit of having a CDN. I'm not sure if it's the second or third, but just in a nutshell, what you get is improved performance and improved security. The improved performance is through caching and through the optimized routing between the CDN and the backend. So this is the simplest definition I could come up with the CDN. It's essentially just a set of reverse proxies distributed around the world, and that's it. And obviously you can rely on Azure CDN if you want to implement CDN capabilities in your applications. Okay. Now there's two major things you need to be thinking about whenever you are dealing with CDNs on Azure or outside of Azure. And the two things are typically validation and duration. So with validation, what do I mean by validation is that whatever you have cached in the CDN, you want to make sure that it is in sync with what you have on the server or it's not out of date. Okay, so let's say that you are caching a specific video on the CDN, okay, that you obviously retrieved from the server. What if this video got edited, it got deleted, etc.? It's going to become out of sync between the CDN and the server. Okay, so this is the validation part. And the way this is solved is by using something called e-tag. Okay, e-tag is essentially a unique string assigned to a resource, like an image, for example, on the server. Okay, and the way this works is that the CDN continuously sends calls to the server attaching this e-tag in a if non-match header. Okay, so this is an example of the e-tag, and if this e-tag is equivalent to the e-tag we have on the server, then we know that they are in sync and the cache is actually still valid. Okay, but if the e-tag sent by the cache is different than the e-tag we have on the server because the resource got modified, the server will actually give back a 200 response or 200 status code back to the CDN with the proper resource. Okay, so this is the way it works. It relies on what is known as e-tags, and it relies on the CDN continuously sending requests to the server with the if non-match header. Okay, and the second thing that you have to think about is obviously the duration. So with the duration, it's obviously how long do you want to keep content cached on the CDN, okay? And this is simply set by the server itself, where it responds back to the CDN with a cache control header that determines how long the content should be stored in the CDN or cached in the CDN. Now let's talk about application insights, which actually forms a good part of the exam. And before I talk about Azure Application Insight, I just want to touch on what we mean by Application Performance Management, or APM software, okay? APM is essentially a software that provides application level monitoring, okay? So maybe you are used to the standard types of monitoring tools that monitor your infrastructure like CPU, memory, etc. With APMs, or Application Performance Management software, those are tools that provide application level monitoring. So they go deep down into your code and they can monitor your code stack, they can monitor exceptions, they can monitor the duration of the specific API calls, they can monitor dependency calls like calls to your databases, etc. So whenever you hear or see the word APM, this refers to tools that provide application level monitoring. And on Azure, Application Insights is the APM service. And if I want to go through this very simple diagram, you have a standard web server and you have a traditional database, and you are interested in collecting application level data from this application, okay? And to do that, you need to rely on a service like Azure Application Insights, and this is the logo for Azure Monitor, actually. So the question is, how do you collect data from those running applications and store them on the Application Insights resource or on Azure Monitor, okay? And the way this works is you would typically install a library inside your application. So it's just like any other libraries. And this library is responsible to collect those data and send them over through port 443 to Azure Monitor. So it's a very simple mechanism. It's essentially just a library, okay? Some other tools rely on things like agents. Okay, you can install an agent, which is essentially just a software on your web server, and that software actually is responsible for monitoring your application to send it over to the cloud, whatever service you are relying on. If you're using Azure App Service, actually, this comes in a click of a button, okay, because Azure App Service actually has a pre-built agent already configured, and all you have to do is just click a button to essentially attach the agent that is already installed as part of the app service image to your app service, okay, or to your instance. Now, what you can collect with Application Insights is essentially exceptions, dependency calls, performance, traces, even custom events, etc. And once you collect this data into Azure Monitor, there's obviously a reason why you have this data in Azure Monitor, or there's a reason why you have this data in a centralized place. The major benefit or the major reason is to allow you to search through this data. Okay, so you have this data in a centralized place and you want to make sense of the data that you have. And for that, you need some search capabilities. And on Azure, we rely on what is known as Custo Query Language, which I will demo in a bit. The second major benefit to having centralized data in Azure Monitor is to actually action on the data. And by action, I mean creating alerts based on certain thresholds that are violated. Okay, so whenever you have data stored in a centralized place, it makes it very easy to search through this data, and it makes it very easy to respond to this data by creating alerting mechanisms. Okay, so this is essentially how Application Insights comes into play with your own applications. And if I want to show a very, very quick code example, by the way, I made a very detailed video on Application Insights that I will link on the video in the description below. It will be actually very useful for you to understand the service in greater details. But essentially, this is an example of Application Insights being configured on a Node.js application. And notice that all I have to do is simply just download this library called Application Insights, okay? And then all I have to do is just set it up with the specific instrumentation key and then call the method start, okay? So this instrumentation key is actually given from the portal, which I will show in a bit, okay? And once I set up Application Insights from my library, it will actually automatically collect information such as dependencies. So if I make calls to my database, it will automatically collect this data, and it will collect things like the response duration from the database to see where the bottlenecks are. It automatically collects requests to my server, so the API calls. It automatically captures exceptions. Okay, so if there are certain exceptions in my code or errors, okay, it will actually capture those and send them over to Application Insights. And something I want to touch on is the reason why we have this instrumentation key is we need a way to identify a specific Application Insights resource. Okay, so obviously every customer will have its own Application Insights resource, and the Application Insights resources are actually segmented by instrumentation keys. Lately, we have things like connection strings, but for the purposes of this call, let's stick with instrumentation key. So every Application Insights resource on Azure will have a unique instrumentation key, and this is a way for you to identify your specific Application Insights resource. This is a key that you need to store in a secure place, because if I have your key, I can essentially send data to your Application Insights resource. So you need to obviously keep it as a secret. So with Azure Application Insights, this is what you get on the portal. Again, I made a super detailed video linked in the description below about Application Insights. So just make sure to check it out if you want to get more confidence in this area before the exam. So with that, you have the overview page, which essentially gives you some out-of-the-box metrics that you can look at. Some of the interesting things to look for is application map, for example, which essentially gives you a visual way of seeing the interactions that your application is making with other components. Okay, so in this case, my application is actually interacting with a MongoDB database, and it's actually interacting with an external API. And another interesting thing to look for is actually the failures tab, where you can check the most popular failures in your application, and you can drill deep down into those failures as well. So here you can see that you get some sample codes that resulted in those failures, so you can check the history that led to this specific failure. Then you can check things like performance. So again, it filters them by the duration, so you can check the API calls with the most duration, etc. And you can drill deep down into performance, just like you would drill deep down into the failures. An interesting thing that you probably will interact with is this search functionalities. Remember that one of the benefits of having your data stored in a centralized location like Azure Application Insights is you can search on this data. Okay, so you can type things like requests, for example, and you can get the history of all the requests that you have in the last 24 hours. And obviously, you can rely on the Kusto query language to drill down into specific data that you are looking for. But the nice thing about Azure is actually they provide you all of those queries out of the box. So if I click on queries in this example, I can check things like that I can alert on. I can check things like performance. So these are a set of queries that are created out of the box by Microsoft or by the Microsoft product group. That essentially saves you some time. You don't have to know the Kusto query language, which is, by the way, super easy to learn. But again, this will save you a lot of time. An explicit thing or a specific thing that was mentioned in the exam syllabus is actually availability tests. So if I go to this availability tab, essentially this tab allows me to create availability tests on my server. Okay, so essentially those are URL ping tests, meaning that the Azure Application Insights service from Microsoft will actually continuously ping your specific endpoints, okay, to check their health. Okay, so if your specific endpoints are not responding to those HTTP calls, then we deem them as unavailable. Okay, so this is why it's called availability tests. Okay, and this is a way to incorporate what we call health checks into your applications. By health checks, what we mean by that is that our service continuously pings your servers and maybe checks if the server will respond back. You can even go as granular as checking how long it takes for the server to get back to you, and then you can define a certain failure criteria. You can go as deep as checking if the content you get back from the server actually matches what you are expecting. Okay, so if I go to classic, add classic test in this example, I can give my test a name, and then here you would provide the URL of your application. So this can be the homepage of your application, and this can be a specific health check endpoint in your application that does a specific check behind the scenes and gives back a response. It can be a lot of different things, and here you can define the test frequency, meaning how many times you want Application Insights to ping your server. It could be 5 minutes or up to 15 minutes. And then you can configure test locations, which is actually interesting. So you can test from many different locations all around the world. Okay. And lastly, obviously here you can define the success criteria. So you can define it based on a timeout. You can define it based on an HTTP response. So if you don't get back a 200, then you know that this is unhealthy. So we can flag it as unavailable, etc. And last but not least, you can also configure things like alerts. Okay, so here you can configure alerts out of the box, meaning that when this specific endpoint is failing, you can get alerts to be sent to you maybe by email, by even Microsoft Teams, etc.